Hi students, welcome to Alpos e-learning chemistry classes for first year. The running chapter is Stoichiometry and now we are in session number 28. In previous sessions we discussed about balancing the equation by ion electron method. All the rules in detail, that too here and there where the media change, there how to approach, how to balance the oxygen and hydrogen in a logical approach. All these we discussed up to previous session, and now we are entering into the other method to balance the redox reaction. It is nothing but oxidation number method. Oxidation number method. Already we know what is oxidation, and now by using that oxidation, here using oxidation number is nothing but we are observing a particular element oxidation state in when it is of in reactant side, and for the same elemental atom on the product side we are considering the oxidation number. If is there any oxidation number change, if there is change, whether it is increased or decreased, in such a manner we have to search. Clear? So when we are considering the change in oxidation number for balancing the equation, that's why the name is oxidation number method. Clear? And now let us take one example, the best known example, so as to understand the logic, that is the principle involved in balancing the equation by oxidation number method is nothing but KMnO4 reacting with H2C2O4, that is nothing but oxalic acid, so as to give Mn plus 2 and CO2. This is the reaction given to balance by oxidation number method. My dear students, already in previous sessions while we are discussing about ion electron method, already I informed you that ion electron method is useful only to learn the subject. That means only to acquire the knowledge it is useful. But the convenient method for particularly for competitive examination, the convenient method to balance the equation is nothing but this one. Because when we are considering the stoichiometric calculations already you know they are applicable only for stoichiometric equation. And what are stoichiometric equation? They are nothing but balanced chemical equation. That means directly or indirectly they ask us before proceeding for calculations we have to balance the equation. So when we have to balance the equation within a short span of time we have to balance it. We should not take much time to balance. That's why. But in case ion electron method, already we solved some balancing equations. There we can find that some numericals are even they are taking 15 to 20 minutes of time also. So by taking that much of time it is not possible to solve the questions in competitive examination to find out the balancing equation. That's why in oxidation number method we can easily balance the equation. That's why I am considering, or not only myself, all the people are considering that this is the convenient method. This is the convenient method to balance the equation. And what are the rules? Let us consider. Here, rule 1. First we have to consider, that is nothing but find out the elemental atoms that are undergoing oxidation and reduction reactions. In first rule we have to find out the elemental atoms that are undergoing oxidation and reduction along with oxidation numbers. We have to find the oxidation numbers along with this. Now let us consider here in KMnO4 Mn, when we find oxidation state, it is observed to be +7, and here in H2C2O4, just you recollect, in case of ion electron method, this potassium and these hydrogens are removed first, but here we are not touching all those such type of atoms, just we are concentrating only on the elemental atoms which are of involving in oxidation and reduction reactions, is it not? Now here it is +3, carbon is with +3 oxidation state, and this side it is +4 oxidation state. Now simply you can observe that this manganese is of undergoing reduction, manganese undergoing reduction, because +7 to +2 the oxidation state decrease, clear? And now in case of oxalic acid, carbon from +3 to +4 it is increasing, thereby it is oxidation. So as per the first rule, we are finding out the elemental atoms oxidation numbers and they which are undergoing oxidation and reduction, we identified them, clear? And now rule number 2, write the 2 elemental atoms undergoing oxidation and reduction along with their change in oxidation number, change in oxidation number. And dear students, it is the first class on oxidation number method, that's why I am giving these rules, literally I am writing on the board. After this example, when we are solving this solving the questions related to this method, I won't write these, just I will dictate orally or I will pronounce them orally, clear? This is the first class for this oxidation number method, that's why I am writing this, clear? And now what they are asking is in rule number 2, write the 2 elemental atoms undergoing oxidation and reduction along with their change in oxidation number. Now just only atoms, just you observe, in this one manganese is +7, clear? And it is now coming to Mn+2, and the change is nothing but -5, that is minus indicates here decrease in oxidation number. And then C2, each one is having +3 oxidation state, and this side it is coming to C+4, but it is only one atom, so as usual we have to consider both these two atoms, that's why 2, and altogether +3 into 2 +6 +4 into 2, that is nothing but +8, so +6 to +8, the change is +2. Are you following? It is nothing but what we are considering is here 2 atoms present with subscript 2. These 2 atoms, here only one atom in each molecule. To balance the 2 atoms we are considering 2 CO2, and for that purpose we need not write here now itself. So when we are considering this carbon and from this carbon, here two carbons present, this side only one carbon present, thereby we are, that is nothing, we are balancing that carbon number. We are taking the number of carbons present on reactant side equal to number of carbons present on product side. That is what we are doing. And now the total oxidation state change in all these carbon atoms from this state to this state is 2. That is what the second rule is. And now we have to go for third rule. As per third rule, balance the 2 changes in oxidation number by multiplying with suitable number of all the atoms. It is nothing but rule number 3. Equalize the increase in oxidation number is and decrease in oxidation number by multiplying with suitable number. This is rule number 3. Here what they are asking is, just let me write Mn plus 7. Actual reaction, okay, we will write that reaction also. Mn plus 7 giving Mn plus 2. The change is minus 5. And C2 with plus 3 into 2 giving 2C plus 4. Change is plus 2. Now we have to equalize these two changes. For that purpose, what we have to do? Multiply this total with 2. Multiply this total with 5. Only with numbers. Clear? And then what we are getting? Then what we are getting is 2Mn plus 7 giving 2Mn plus 2. And the change is minus 10. And 5C2 plus 3 into 2 giving 5 into 2 10 C plus 4. Here the change is plus 7. Now what the rule number 4 says is cancel these two. That's why we are equalizing the increase in oxidation number with decrease in oxidation number. Clear? And now we have to, what is the reaction given? Let me write. Actual reaction is KMnO4 plus H2C2O4 giving Mn plus 2 plus CO2. This is the reaction given, is it not? And now we have to use these coefficients with respective species. That is, in this balancing the oxidation numbers, that is nothing but in cancelling the oxidation numbers, we are multiplying the equation with suitable numbers, is it not? After that, what we are getting as the coefficient, we have to observe that coefficient is present in this species, for this species where this ion is present. Just Mn plus 7 is present here, is it not? So this is of taking 2. Thereby the total chemical molecule will take 2. And C2 is taking 5. C2 is present here. Thereby here we are writing 5. And then Mn plus 2 is taking 2. So it is 2. And C plus 4. Where C plus 4? In CO2. Is it not? So before that 10 we have to write. So now 2KMnO4 plus 5H2C2O4 giving 2Mn plus 2 plus 10 CO2. Here you can observe that other than oxygen and hydrogen, all the remaining atoms get balanced. 2K. K is not there. Already we discussed in previous session. It is nothing but spectator ion. Is it not? And now Mn, 2Mn. And oxygen, we need not go. 2 carbons, 2 into 5, 10 carbons, 10 carbons. Now what we have to do is, in case if you are interested, we need not go for that. For calculation purpose, simply from this equation we can say that 2 moles of KMnO4 can react with 5 moles of oxalic acid. Are you following? 2 moles of KMnO4 can react with 5 moles of oxalic acid. That is the meaning. And now when we are of having other than oxygen, hydrogen, potassium is there. Simply you can write, because it is spectator ion. What is spectator ion? The ion which is present in the solution, but it is not taking place it is not involved in any reaction. Is it not? So that one. Next, water. It is acid medium. Water should be in the form of H2O. That is, oxygen should be in the form of H2O. That is water. Here it is 2 into 4. how many? 8 oxygen atoms. 5 into 4, 20. Totally 28 oxygen atoms are there. And this side 10 into 2. 10 into 2. 20 oxygen atoms there. Remaining 8 oxygens you have to write as water. 8H2O you can write. Clear? And now when it is 8H2O, just you observe, oxygens now balanced, hydrogens. Here how many hydrogens? 10. 5 into 2, 10 hydrogen atoms. But here how many? It is 16. So the remaining 6 hydrogens you have to consider as H plus. That means what we are using, the species for balancing oxygen and hydrogen in acid medium, that species directly you can use to balance oxygen and hydrogen. And the main criteria is only to balance the main chemical species. After that, whatever the oxygens it is involving, whatever the number of hydrogens it is involving, simply you can balance by adding H plus or by adding H2O. In case if it is basic medium, by adding OH minus also you can balance the oxygen. Like that we have to balance. But in most of the cases they are not asking about the balancing of hydrogen, oxygen or potassium like that. Just after completion of this, 2KMnO4 plus 5H2C2O4 giving 2Mn plus 2 plus 10 CO2, that is the balancing equation. Particularly if they are asking for how many water molecules involved, how many hydrogens involved, then you have to consider, or otherwise you need not worry about that. Are you following? Now the equation is balanced. Just again I am repeating, in oxidation number method what we are doing is, first we are identifying the elemental atoms which are undergoing oxidation and reduction. That means which is of increasing its oxidation number, which is decreasing its oxidation number, we are identifying them. Then as per rule number 2, we are writing these atoms, only atoms, we should not consider the chemical species where the atoms present. Just we have to pick out the atom along with its oxidation number, and we have to write the change in oxidation number on extreme right side. And one reaction where oxidation takes place, we can observe increase in oxidation number, and in reduction of reaction we can observe decrease in oxidation number. When we separately mention this change in oxidation number like this, we have to see that as per rule number 3, we have to see that these two, that is nothing but increase in oxidation number is equal to decrease in oxidation number. We have to see like that. That means we have to make like that, and by using or by multiplying with suitable number, and like this. Here when minus 5 plus 2, these two are crisscrossed because one is odd number, the other one is even number. That's why we are making it crisscross. And then we are getting this. Now we are using these for a chemical atom or ion, whatever the coefficient present, that coefficient we have to use in the given reaction as the coefficient of the chemical molecule or species where that ion is present. Here you observe Mn plus 7 is actually present in KMnO4. So as Mn plus 7 is taking 2, here KMnO4 is taking 2. And Mn plus 2 is taking 2, that's why Mn plus 2 is taking 2. And see here carbon plus 4, in which species it is present in plus 4 oxidation state, that is taking the 10 as the coefficient. After completion of these adjustment of the coefficients for the respective molecules, we have to observe whether the hydrogen oxygen are balanced or not. In case if they are not balanced, you need not worry. But if particularly if they are asking, just you have to balance the oxygen by adding water in acid medium. It is nothing but related to ion electron method, and by adding H plus for hydrogen. And in basic medium we have to consider oxygen balance in terms of OH minus and hydrogen in terms of H2O. Is it not? Like that we have to balance in oxidation number method. Are you following? in case if you are not getting, because it is a tough job, while you are learning it is a tough job. So once, twice, thrice when you are going through this video, you can get the idea, you can get the rule. What is the rule? What we are doing for that rule. After getting that, you can easily solve the questions. Clear? And now let me give two examples, that is nothing but two reactions to balance as homework for you. In the next session I will solve those two by oxidation number method, and thereafter we will enter into the other concept of stoichiometry. So these are the two examples what I am going to provide you to solve on your own. My dear students, just follow my suggestions. When you are solving the numericals, to take any suggestion or any help from elders. If you are taking the help from others, automatically you will have that bad practice. Unless otherwise some other persons are supporting you, you are unable to solve. But you remember, when you are in competition for the competitive examinations, you should be having the capability to solve the questions on your own. That's why, in case if you are not getting the idea, again and again, because it is not one time teaching, here we are doing the video. That's why, in case if you are not getting to that rule, again and again you can go through the video, and thereby you can get highest grip on this. That is nothing but you can easily get from the video. Clear? And now solve these two. It is nothing but K2Cr2O7 with H2C2O4, where the products are Cr plus 3 and CO2. And now let me give one more. It is KMnO4 plus FeSO4 giving Mn plus 2. It is in acid medium, just you remember, plus Fe plus 3.